Hello children, welcome to another lesson on SBC TV. I am Gopaul from English River Secondary School. Our topic for today is a chemistry lesson based on salts, making salts. So here are your lesson objectives. Read it. Now, maybe you were expecting to see some white crystals, the salt that you use in the kitchen at home, which is a salt. The chemical name is sodium chloride. But sodium chloride is not the only salt. This one salt that you are seeing here is a blue crystal of copper sulfate. And you will remember earlier, we mentioned that a salt is a substance formed when the hydrogen of an acid, they are partly or completely replaced by a metal or ammonium ion. The hydrogen of an acid is replaced by a metal or hydrogen ion. That is a salt. Therefore, copper sulfate is one, sodium chloride is another one. Now, there are two types of salts, those that are soluble and those that are insoluble. There are different methods for preparing them. Let us follow them. Firstly, in our last lesson when we were studying acids and alkali, there were three important reactions I wanted you to know: acid and metal, acids and alkali, or a base, acids and carbonates. All these reactions, they do produce salt. So, soluble salts can be made by reacting an acid with a metal, with a base, or with carbonate. You studied it earlier. Now, we will start with soluble salts, and then we'll come with the insoluble salts. Now, soluble salts, you can react excess. This is my shorthand way of writing EXESS. It's excess of insoluble metal oxide or carbonate. Or if your materials or reactants are soluble, you will have to choose another method, that is a titration method. We'll start with the insoluble one. Let us take a metal like zinc reacting with an acid in a beaker. Right? Now, what is it that tells you a reaction is happening? You have added zinc to an acid. What is it that tells you that a reaction is happening? The bubbles. It is a bubble that is happening. It tells you that a reaction is happening. Now, let us look at the reaction. In a reaction, you have got the reactants, the substance that are reacting, and the substance that are produced. These are the products. You are interested with the salt. And in this case, it's a zinc sulfate. You are not interested with any one of them. Now, let us say the reaction has stopped. No bubbles coming out. Now, does it mean that sulfuric acid is over? You cannot say it. You can see the zinc. If you don't see the zinc, you can say, yes, the zinc is over, but you cannot tell that the sulfuric acid is over. But if the reaction has stopped in the presence of zinc, then you can confidently say that there is no more acids. Do you get this point? This is the only thing you can see in your vessel, the zinc. These ones you cannot see. This is also an invisible gas. You see it as bubbles, which is going out, but you cannot see anything there except the zinc. So, when the reaction is over, you will be left, if you have used excess of zinc, you will be left only with zinc and zinc sulfate. You will be left only with zinc and zinc sulfate, and this zinc is a solid. You can just remove it by filtration. This zinc sulfate is aqueous. It means that it is dissolved in water. You get rid of the water by evaporation, and you get your zinc sulfate. So easy than that. Okay? Now, this is how it goes. You make your reactions. Your unreacted zinc, you remove it as a residue by filtration. Your aqueous solution, you remove your aqueous solution. Well, we'll come to that another step. So here you have removed the zinc, and here you heat the solution to remove the water, to evaporate the water, and you obtain a saturated solution. There are two ways of getting your crystals. You can evaporate your solution to dryness, or you can evaporate it until you get a saturated solution, and then you leave this solution to cool. You will get crystals in your vessel. Why do we carry out these methods of saturating your solution and that getting your crystal? This is when you need pure crystals. Only the zinc sulfate will come out. Other things will stay dissolved in the water, you will not get it. But if you are not concerned with purity, then you can carry out evaporation to dryness. Right? So, if purity is needed, you carry out these methods, or if you are not interested with purity, you just evaporate to dryness. So, these are the 3 steps. Do your reaction, filter, then evaporate to dryness if you are not interested with purity, or you crystallize if you are concerned with purity. This is a summary, what we have just studied. Okay, reaction, remove by filtration, evaporate, and everything. Let us look at another reaction now, using a base, which is copper oxide, which is a black solid, reacting with sulfuric acid to get copper sulfate. Right? Again, this, when you see the S, it means it is a solid. It means that it is insoluble. So again, same as the metal, you have an excess of copper oxide reacting with your acid. When the reaction is over, when you see that there is copper oxide left behind without any reaction happening, you know that the reaction is over. You will be left with copper oxide, which you can remove by filtration, and you will have your copper sulfate, and you can just evaporate or crystallize to get your salt. Same things. Okay? And it will going to be the same type of reaction with insoluble carbonate. But if your reactant, your base or whatever is soluble, you cannot carry out the other method. Then you have to do titration method. You use a pipette. I hope you have seen it. You must have done it at the beginning of the year in terms of apparatus for measurement. You use a pipette to transfer exactly, because this one is very accurate in the volume you use. So you transfer 25 centimeter cube of dilute hydrochloric acid in a flask, or whatever acid. If you want nitric acid, if you're preparing a nitrate, or sulfuric acid, you're preparing sulfate. I mean, you transfer your acid into a flask. And since here you will not see anything, neither the acid, neither the alkali or the salt, so you need an indicator. The indicator will tell you whether the acid is still around or not. So, the first thing you do, you transfer your acid, 2 drops of methyl orange or any other indicator, and then let us study the reaction. Sodium hydroxide is colorless, it is aqueous. Hydrochloric acid is colorless, it is aqueous. Sodium chloride, when it is dissolved, it is colorless, aqueous. And water also is a liquid, it is colorless. So there is nothing here you can see, no bubbles, no solid, nothing. This is why we need the indicator to tell us whether this one or this one is still around. Because these are the reactant, and we are not interested with any one of them. This one, we are not interested, we are interested only with the sodium chloride. So, what we do next, here is what happens when you are adding your acid and the alkali. The hydrogen from the acid will react with the OH from the alkali to form water, which will give you a neutral solution. That is a reaction. Now, when you have your acid in the flask, now you add your sodium hydroxide from the burette, drop by drop, little by little, until this solution becomes yellow. The yellow color is the alkali color. Now, actually, you don't get the yellow. You have to get the end point, which is a color between red and yellow, which is around this color. This is the end point. And remember, you have to look at the color to have a good contrast against a white background. You need this is why we put a white tile on our retort stand, so that you can get a good contrast of the color. So now what you have, if we go back here, the indicator tells us there is no sodium hydroxide, no hydrochloric acid. There is water, which is not a big problem because it is aqueous, but the indicator is there in the first experiment. So this is going to be a source of impurity. We are interested only with the sodium chloride that we are preparing. So what you do, when you have carried out the first experiment, you find out how much of acid you have used from the burette. Right? Then you do the experiment again, this time without using the indicator. You know, you used 25 centimeter cube of acid and you added, let us say, 37 centimeter cube of alkali. This is what you have, you got while using the indicator. Now, you repeat the experiment, this time without the indicator, using the same amount of acid and the alkali, and you know, you have got the exam volume reacting with the exam volume. So you repeat without the indicator, and then you just carry out your evaporation or crystallization. Okay? So that is the second method, the titration method. Now, see if you can answer this question. Soluble salts can be prepared by reacting what? With metal bases or metal carbonates. The salt can be obtained by the water from the resultant solution. I give you 1 minute, look at it. Try to find the two missing words. Okay, did you say acid in the first instance? You have to react acids in order to get the acid radical, and then you have to get rid of the water, so you evaporate the water from the resultant solutions. You got it? Clap for yourself. Good. We move on. Now, let us come to insoluble salts. Insoluble salts, like, look at here. Potassium iodide is a clear solution. Lead nitrate is also a clear solution. But lead iodide is a yellow solid. So you just take the two, you mix them together, no need for excess, no need for anything, and you will get your lead iodide. This is precipitation. You get an insoluble solid form, which is called a precipitate. And then this one, you can just filter it, wash it, dry it in an oven, and you get your salt. This is a simple method, and it is an objective for extended candidates, but it is simple. Look at it again. So, you have potassium iodide, which is colorless. You have got lead nitrate, which is colorless. When you mix them together, you will get your lead iodide, which is a solid, which is an insoluble salt, and then you will get your potassium nitrate. There is a changing of partners here, okay? And this one is aqueous. You filter, everything will go away as a filtrate. If this is in excess, this one or whatever, they will just be collected as a filtrate. This one here will be collected as a residue, and this is what you are interested with. You get your insoluble salts by precipitation. So, do you understand it? Try to see what goes here. Insoluble salts are prepared by precipitation. This is precipitation means a solid that is formed when two liquids react. And how do you get the solid? It's by filtration. Can you digest it? Do you get it? Make sense out of it? So we have come across all the methods we use in preparing salts. Okay? Now look at this. Soluble and insoluble salts. Sodium, potassium and ammonium salts are all soluble. All sodium, potassium and ammonium salts are soluble. Nitrates also are all soluble. It's good to know it. When it comes to chloride, they are all soluble except lead and silver. These two are insoluble. You get them as precipitates. When it comes to sulfates, they are all soluble except calcium, barium and lead. These are the exceptions. And when it comes to carbonates, they are all insoluble. All carbonates are insoluble except, as I mentioned here, sodium, potassium and ammonium. It is good to know this, but usually in an examination they do give you information about these salts. Right? Now, I have a problem for you. Which substance will produce an insoluble salt when aqueous solution of them are mixed? It's a multiple choice, trying to find out which is the correct answer. You have around a minute to answer this. Now, barium chloride is soluble. Magnesium nitrate is soluble. So, calcium chloride is soluble. Ammonium nitrate is soluble. Silver nitrate is soluble. Zinc chloride is also soluble. But remember what you want to prepare. An insoluble salt. Now, when you mix barium chloride with magnesium sulfate, you will end up having barium nitrate and magnesium chloride, changing of partners. Barium nitrate, magnesium chloride, they are both soluble. When you are mixing calcium chloride and ammonium nitrate, you will end up with calcium nitrate and ammonium chloride. Again, both are soluble. When you mix up silver nitrate and zinc chloride, you will end up with silver chloride and zinc nitrate. And we just mentioned that silver chloride is insoluble. Here we are. So the answer is C. Barium sulfate, as I mentioned earlier, this is another insoluble salt. So how you prepare it? You make up solution of barium chloride and magnesium sulfate. Remember, one has to have the barium and the other one needs to have the sulfate so that they change partners and come together. Don't. Barium chloride, magnesium sulfate, when they are mixed, you will get a white precipitate of barium sulfate, which you can filter. Then you wash it and then you place it in an oven to dry it. Remember again here, your barium sulfate is collected as a residue. But what do you collect as a filtrate in this reaction? What were you going to collect as a filtrate in this reaction? Barium sulfate is a residue. So you will collect magnesium chloride as a filtrate. This one is soluble. It will go through the filter paper, you will collect it in the receiver. I hope this is making sense to you. So, a summary. Two types of salt, soluble, insoluble. For the soluble, you react acid with an excess of insoluble metal, oxides or carbonates. Or you have the titration methods using an alkali and a acid with an alkali or a soluble carbonate, titration method. For the insoluble salts, we just studied, you use the precipitation methods whereby you mix solutions of two soluble salts. Okay? Now, look at this. I have run out of the insoluble salt lead chloride. I don't have it in my laboratory. I don't have. I want to prepare it. Right? Now, which two salts must I use to prepare lead chloride? Remember, I want lead chloride. Which two salts must I use to prepare lead chloride? And what are the products formed? Now, I need information about salts. And here's the information about salts I give you to use. Huh? You have calcium sulfate. It is insoluble. You have copper sulfate. This one is soluble. You have lead nitrate, which is soluble. Lead sulfate, insoluble. Silver chloride, insoluble. Sodium chloride is soluble. And sodium nitrate is soluble. And which salt do we need? We are asking to prepare lead chloride. So, can we use this one? No way. Can we use copper sulfate? No. Because I don't have lead and I don't have chloride there. Useless. Shall I use lead nitrate? Yes, because there is lead around and it is soluble. So, I will use lead nitrate. Can I use lead sulfate? It is insoluble, it's not going to be useful. Can I use silver chloride? It is insoluble, it is not going to be useful. Can I use sodium chloride? Right, I need what? Lead chloride. So yes, I have the chloride ion here, I have the lead here, they are both soluble. Therefore, the two salts I will use to prepare lead chloride are going to be lead nitrate and sodium chloride. They are both soluble, so when they change partners, I will end up with lead chloride and sodium nitrate. This is another question. Is it going to reinforce what we just learned? Huh? Because we are almost over with the topic, we are just reinforcing what we just learned. Look at this one. Copper sulfate is a blue crystal. This is why I put the font in blue. They are made by adding an excess of copper oxide to sulfuric acid. The mixture is heated. Why is it heated? To make the reaction go faster. Again, why is it stirred? Again, to accelerate the rate of reaction. Right? So, after the reaction, it is filtered. And the filtrate is allowed to evaporate, leaving the crystal. Now, why do we filter? Why do we filter? Is it to remove the soluble properties? Is it to remove sulfuric acid? Is it to remove the blue crystals? Well, you know that filtration is used to remove an insoluble substance from a liquid. So, does not make sense. Sulfuric acid, you will never be able to remove it. And you don't have any blue crystals here. This is only after evaporating that you get the crystal. So, the answer is D, whereby you remove the unreacted copper oxide. Remember, I said earlier, you have to add the copper oxide in excess. And this is removed by filtration. So, the answer is D. Another problem for you. I have an excess of substance Z added to some spilled acid. You have got some acid on the floor, you add a substance to it, and the solution that is produced as a result of this is neutral. What have I added? What is that? Is it aqueous ammonia? Because ammonia is alkaline, it will react with that acid, it will neutralize it, sure. Can it be sodium hydroxide? Again, this is an alkali, it will react with the acid, it will neutralize it. Can it be calcium carbonate? Yes, it will react with the acid to produce salt, water, and carbon dioxide, which are all neutral. You can use it. Can it be water? Now, let us study. Remember, you have added an excess of ammonia solution. So, if you have ammonia solution in excess, you are not going to get a neutral substance at the end. It's going to be alkaline. If you are adding sodium hydroxide in excess, the result is not going to be neutral. So it cannot be again B, because this is being added in excess. But when you add calcium carbonate, even if it is in excess, you will have salt, water, and carbon dioxide. Carbon dioxide will just go away. It is a gas. So you will be left with the calcium, salt, and water. So this is going to be neutral. If you have added water, water is going to dilute the solution. It's not going to remove the acidity. It will just dilute it. So the acidity will remain. So the answer is C. Look at this one. Calcium, calcium carbonate, calcium oxide, they are reacting separately with hydrochloric acid. Calcium and hydrochloric acid, calcium carbonate, hydrochloric acid, calcium oxide and hydrochloric acid. 3 different reactions with the same acid. And they produce the same salt. What is that salt that is produced? So, you are using a calcium base or calcium carbonate or calcium metal with a hydrochloric acid, you will have calcium chloride. So this is going to be your salt. Your salt is going to be calcium chloride. Do you get it? You are using calcium or calcium salts or a base made up of calcium, calcium oxide, reacting with hydrochloric acid. The salt that you get using hydrochloric acid is a chloride, and the metal bit is calcium. So the salt is calcium chloride. This is a salt. Now, gases are involved in some of them. Okay? Now, name the gas, if any, when each of the 3 substances reacts separately with hydrochloric acid. Now, do you get any gas when you're reacting calcium with hydrochloric acid? Do you remember the reaction? Metal plus acid will give you salt and hydrogen. Therefore, the gas here is hydrogen. When you're reacting a carbonate with an acid, you will get the salt, carbon dioxide, and water. So the gas here is going to be carbon dioxide, and when it comes to calcium oxide, there is no gas. So when you are using calcium, you get hydrogen. When you are using calcium carbonate with the acid, you get carbon dioxide gas produced. And when you are reacting calcium oxide, there is no gas produced. It's just the salt and water. Remember this reaction I gave you when we were doing acid and alkali. And here again it's coming out. Acid and metal, hydrogen. Acid and carbonate, carbon dioxide, water, and the salt. Acid and oxide or base, salt and water. No gas is produced. Look at this one. Copper sulfate can be prepared by adding excess copper carbonate to sulfuric acid. By now you should understand the purpose of why we use excess. Now, why is an excess copper carbonate added? Easy. To ensure all the copper carbonates has reacted. This is why we add it in excess. Is it to ensure that all the sulfuric acid has reacted? Is it to increase the rate of the reaction? Or is it to increase the yield of copper sulfate? I hope earlier I did tell you why we use the insoluble substance in excess. It is to make sure that all the acids has reacted. Therefore, the answer is B. Look at this one. Compound P reacts with hydrochloric acid to produce a gas that turns lime water milky. Which gas turns lime water milky? You should know. It is carbon dioxide. Therefore, what is P reacting with the acid? Can it be sodium carbonate? Of course. Can it be sodium chloride? No way. Sodium hydroxide? No way. Sodium sulfate? No way. Therefore, the answer is A. Right? Another one. I hope you are able to see this one. Apparatus is used to prepare copper 2 sulfate. So, you heat, you have a stirrer, you have Y. What is Y? And you are adding solid X. And you are preparing what? You are preparing copper sulfate. So, can you be using copper and iron sulfate to prepare copper sulfate? No way. You will learn it later when you have done electrochemical series, reactivity series. Copper is lower than iron in the series. It will not going to displace it. Can it be copper chloride and sulfuric acid? Does that occur that way? Copper oxide and sulfuric acid. This is what we have been studying so far. This is a base and this is an acid. So by reacting a base with an acid, you can get the salt. So the answer is C. Okay, so look what happens. You do the reaction, you filter, and then you evaporate. Reaction, filter, evaporate is C. Right? So, we have come to an end for today's lesson. I hope you have been able to answer some of the questions we've been putting forward. Now, you have to do some self-learning because what you learn, you forget. So, you do some self-learning. You have to go through your books, any book you get on chemistry. You read the chapter, you read the topic, and then you try to attempt the end of chapter question. Almost all books, they do have an end of chapter question after each chapter. Try to answer them. And if you are having difficulty, consult your teacher. Thank you.